Hi everyone, let's talk about stream processing within BangDB. So if we go to the schemas page, we see a lot of schemas that are registered with the BangDB are showing up here. So think of stream processing as data processing where various events from various different sources are getting ingested within the BangDB. And as those events are flowing in, we would like to do certain processing. And when we process, our main goal would be to find out certain patterns into it. Those patterns could be positive, negative, anomalies, or any statistical modeling that we would like to do on those data. We may want to predict on those events, and based on the predicted value, we further would like to do some statistical analysis. And when those patterns or interesting events are found, we would like to send notifications to the user. This is pretty powerful because now we have an opportunity to continuously process every single event that are being ingested within the BangDB. And when this data is still in the wire, in a sense that data has not yet persisted on the disk, we can do a lot of processing. This whole thing is enabled by the stream processing engine within BangDB, which basically works on various sliding window table. And then how do we process those data? What do we do with the data? What kind of patterns we would like to identify? And what happens when pattern is identified? These logic could be defined in this schema. So these schemas that we are seeing are nothing but collection of set of streams. And for each stream, there is a collection of different activities that we would like to do. So typically, if you see this schema, it looks something like this. So this is the car schema. And within car schema, we have a sensor stream. The sliding window of the sensor stream is 1 day. Then we have attributes defined for that particular stream. For example, time, the car ID, the coolant temperature, intake air temperature, intake airflow speed, battery percentage, battery voltage, battery, the speed, the engine vibration amplitude, throttle position, and so on. Now, these are some of the attributes that we are ingesting. Further, we are computing few more attributes, and these are called CATR, which is computed attributes. And the way we are computing these new attributes is by using a model called coolant model. This model is also trained within the BangDB. And once the model was trained, as we are ingesting the data, the BangDB stream processing engine would use this model to predict a coolant temperature. And the predicted value will be stored in the projected coolant temperature. Similarly, there is a speed prediction happening. We are using these many attributes to predict this speed. And this is being done using the speed model. Now let's look at some of the events, some top events which are there in the system. So we see that typically there are a lot of attributes that are being ingested in this event. And then in the end, we'll see the predicted value also. So we'll see speed prediction is this and projected coolant temperature is this. And there are some differences. And based on that, we are taking certain action. This is typically a very high level overview of these schemas. We will discuss in detail about schema in separate video. Now let's actually see what's happening on this page. So this page is listing all the schemas, and each row is depicting one single schema. The first column is the name of the schema. The second column talks about how many streams are there in this schema. The third column talks about how many events are there in this schema. So for example, if you see the taxi schema, you will see that it has close to 9.5 million events. If you see this schema, there are more than 53 million events here, and so on. Now, if you see the fourth column is about switching off or switching on this schema. So we can at any time change the state of the schema so that the stream ingestion and the processing stop. We can go and check out the details of the schema. So let's check out the details of the schema. It is nothing but a JSON document, and it defines the collection of streams, and for each stream what are actions that we want to take. So some of the actions typically are creating new attribute, which we call CATR, filtering the event based on certain condition. Then we can join this stream with other stream and send the data to third stream. Then we can identify some patterns using complex event processing, which we call CEP. Further, we can maintain some long running data and statistics into entity stream. We can define the relationship between various attributes and push the data into the graph. We can refer some other stream and get the data from that stream and enrich this stream, and so on. There are many activities that we can do. And all of those activities are nothing but configuration which goes into the schema JSON. We also have dependency graph for each schema. If you click this button, you will be able to see the dependency graph. So this is typically how the dependency would look like, or you can simply visualize here. If you go here, The dummy head is nothing but the main parent for all the streams. These blue circles are streams, and there is a relationship between these streams defined here. Then we can go and delete the schema using this delete button. But if you click on the stream section, you will see how many streams are there, and for each stream you will see how many events are there. If you click the refresh icon, the number of events in that stream will get updated. So this is very high level overview of the schema, and we'll discuss about the details of the schema and how do we create those schema in subsequent videos. Thank you very much.